Good afternoon, everyone. Welcome to day one of Smart Buildings Week presented by the Smart Building Center. My name is Stan Price, and I'm joined by my colleague Britton Reif from the Smart Building Center, who you don't see here, but whose magic fingers will be controlling our Zoom screen today. I want to just start off before I introduce our panel to thank our event sponsors that you see on the right-hand side of the screen. So many thanks to Microsoft and to McKinstry, Seattle City Light, Puget Sound Energy, DB Engineering, Long Building Technologies, ATS Automation, the Seattle King County chapter of BOMA, and the Washington State Department of Commerce, as well as BELIMO. So thank you to our sponsors. Without them, we wouldn't be able to put together what's going to be, I think, an exciting week of discussions about the smart buildings marketplace. Before I introduce the panel, then again, I would like to have Britton just tee up a short welcome from our title sponsor, Microsoft.
As the title sponsor of Smart Buildings Week, I want to welcome you to this free webinar series. The Smart Building Center has put together a lively and engaging series of free webinars that will discuss some of the important technologies and practices in the fast-growing markets of smart buildings. At Microsoft, we see incredible potential of using IoT, AI, and other technologies to transform the built environment, and not only for improving energy efficiency and building operations, but also in creating new opportunities for enhanced organizational productivity and in creating and maintaining a healthy and safer environment to live and work. This webinar series will explore ideas in smart buildings and places that are practical considerations today for both building owners and operators. The sessions will discuss successful examples of how smart technologies and practices resulted in improved building performance that persisted over time. In addition, these sessions will explore how new relationships are being crafted between electric utilities and the customers they serve to create new economic and environmental value for all parties. In the final webinar of the series, my colleague Spiros Sakalariadis will present Microsoft's perspective on how smart buildings fit into the growing market of IoT and our view on the present and future of smart buildings marketplace. Microsoft, along with a host of businesses and utility sponsors of this series, welcomes you to the Smart Buildings Week. I'm certain that you will enjoy these informative sessions.
Great. Thank you, Rhymes, and thanks to Microsoft for their sponsorship. I should also correct an error because I happen to have neglected to mention McDonald Miller as also a sponsor for our event today as I read out that list. So again, special thanks to McDonald Miller for their sponsorship. Well, sadly, everybody on the call today is probably very experienced in Zoom calls, so I probably do not need to give you a whole lot of instruction. As you might have guessed, that your microphones and your cameras as participants have been disabled, but that doesn't mean that we don't want to hear from you. There is a Q&A dialog box which you can navigate to quite easily. We have disabled the chat function box just because we didn't want to be redundant. So if you do have some questions along the way, please put them in the Q&A dialog box. We'll monitor as we go along and try to get to as many questions as we can during the session today. Okay, off to the panel. We have a really excellent group of folks to talk about this issue today. I'm going to actually let them do their own introductions, but I'll say their names. Pete Siegel is here, Keith Brogobin is here, Tim Wingard is here, and Trevor Sodorf is here. And so I'd like to just kick things off. People can associate a name and a face together. To have you start as Pete. Tell us a little bit about what you do at ATS Automation and your role in smart buildings.
Yeah, so again, my name is Pete Siegel. I'm the Energy Services Manager with ATS Automation. I've been in the energy management facility solutions field for over 24 years. I currently oversee a team of building performance engineers, project managers, energy engineers with the core mission of better building performance through optimizing energy management systems, leveraging state and local utility incentives for building performance upgrades, and developing new and innovative facility solutions. The core of ATS's business is engineering, installing, integrating, and developing new and innovative building automation energy management systems. And this is why I'm so interested in smart buildings and where they're going, because my world really lives at the intersection between building efficiency and building technology. And I first got involved in analytics about 7 years ago, because being in my world, I've seen way too many buildings that operate poorly, yet no one was really aware of this poor operation. And analytics have really been a means to bring what is important for better building performance and operations to light.
Great, Pete. Thanks for joining us today. Trevor, you're up next.
Hi, everyone. My name is Trevor Sodorf. I'm the Director of Engineering Analytics for a company called DB Engineering. We're based in Redmond, and we are really a smart building consultant. We specialize in mechanical engineering, but with a data flavor. We believe that a lot of the problems that exist in buildings today are solvable and can be solved with the use of data. And so it's our job with our customers to help us traverse that landscape, make sense of, huge volumes of data and try and come up with measurable and practical solutions. Practicality is really the key there. And I would echo Pete's sentiment in that there are a lot of problems in buildings today, and we can detect a lot of them. Fixing them is somewhat of a challenge, and hopefully we'll get to talk about that a little bit more today. So thank you.
Excellent. Thanks, Trevor. Tim, you're up next.
Thank you, Stan, and good morning, everybody. My name is Tim Wingert, and I'm a Chief Building Engineer for Seabury here, South Lake Union District of Seattle. I oversee engineering operations of 4 Class A office properties totaling about 1.4 million square feet of rentable space. I have a team of 12 building engineers, and we work in coordination with our 8 property management personnel. I'm responsible for maintenance and improvement of all building mechanical, electrical, plumbing systems, as well as budgets, manpower, and a host of other things, to include, of course, sustainability.
Great, Tim. Thanks for joining us today. And Keith?
Hi, I'm Keith Verkoben. I am the technical lead of an internal team at Google that works on technology for using and building applications against the data that we get out of our buildings. And we are responsible for things like sustainability, user experience, and various other things. And so my role in this is really figuring out how do we make building data usable at scale across a huge portfolio. So we have hundreds of buildings globally, tens of millions of square feet, and we're trying to make it so that we can actually see all of these buildings as one set and operate on them in similar ways globally.
Great, perfect. Well, this is a perfect group for this discussion, and we want to start out by spending some time sort of discussing the state of smart buildings today. And I'd like to kick off that discussion by having Tim and Pete certainly talk a little bit about the buildings that Tim manages for CBRE and how they have recently worked together to improve performance in this Seattle building. And I think they've got a couple of PowerPoint slides that they may use to help illustrate that. So go ahead and kick us off, you two, and Britton will bring up the slide.
Go for it, Tim.
Okay. Thanks again, Stan. So one of the properties we want to talk about is one that I manage. It's relatively new. It's 5 to 6 years old. Typical office uses and pretty standard building systems. It's a LEED Platinum rated property comprised of 2 mid-rise buildings totaling about 400,000 square feet. The property.
And, I'm sorry, Tim. Britton, could you bring up that first slide? Thank you. There you go.
And Tim, I'm going to have to apologize right away because I built this slide and I thought it was only LEED Gold. So apologies out there. This is
that's fine. It originally was LEED Gold. I mean, but we've made some improvements since then. So, yeah, no worries.
And I'm sorry, did I catch the year that this building was built?
2015.
2015. Thank you.
So the property came with some challenges. Being independently owned, occupied primarily by a single tenant, it resulted in a lot of some high performance and management expectations. That took a lot of coordinated effort to conquer. Tenant operations include a lot of regular space reconfigurations, many changes to personnel densities, space uses, and so we found ourselves challenged with limited resources in a very dynamic operating environment and some very high expectations, especially with LEED Platinum as a standard. So with concern for employee comfort, business continuity, and a constant eye on efficiency and LEED qualifying operations, our discussions revolved around how can we be more proactive in identifying and addressing unseen issues before they result in larger, more noticeable problems. Most of our work orders pertain to HVAC comfort, so we started with the BAS, the building automation system, by just asking ourselves, how can we better utilize the data present with our existing Allerton system to meet our goals, and that brought us, of course, to the subject of analytics. And so Pete Siegel and the ATS team have been involved in our property since day one, since construction. And so we consulted his team on what our options are and what's the benefit of implementing analytic tools. What would those benefits be? The impact would be to our goals in trying to be more proactive and less reactive, and of course, minimizing any costs involved with these improvements.
Yeah. So Tim came to us, or actually it was Tim's predecessor came to us in all actuality, but so way back in 2015, ATS, as part of the building construction contracting team, we completed the installation, the integration and commissioning of the Allerton building automation system at the site. The building had a top-tier construction team. It was fully commissioned by a third-party commissioning agent. At the time, it was LEED Gold certified, now Platinum, but at the time, LEED Gold. And it was being operated by CBRE, as we all know, world-class leader in facility management. However, as Tim mentioned, because of this tenant, the building was extremely dynamic in terms of space use and tenant requirements, which made that first year of building operations and opening really challenging. In addition, there were some interesting operating challenges to contend with, like how the HVAC systems interacted with operable windows. That became a challenge. And as we know, when we do commissioning in empty buildings and watching an occupied building operate with dynamic use, they can provide very different operating scenarios between the empty building commissioning versus an occupied building. And you can see the quote on the screen from past ASHRAE President Bill Harrison that most buildings will lose up to 30% of their efficiency in the first 3 years of operation. You can pretty much bet on the fact that buildings don't get more efficient over time on their own. Efficiency tends to drift if not being watched. So working with the CBRE team during that opening year of operations, we put together, call it an analytics program, call it ongoing commissioning, call it continuous commissioning, machine-based commissioning, pick your name, whatever you want to call it. We put together a program to support the building operations. And we'll get into a little bit of the details later on, but in general, this service really revolved around, first of all, deploying an analytics platform. We happen to use SkySpark, but deploying an analytics platform to integrate normalized data from the building automation and electrical metering system, and then running rules and faults against this data to identify issues. Then as a team, we would meet on a monthly basis to discuss building performance and the known issues and determine, who's responsible for correcting these issues. And essentially the next month we, meet and repeat, all the while trying to hold each other accountable for the work that we're doing. And I'd say this, the process wasn't perfect. It still evolves. And I think some of Tim's team, they probably get sick and tired of me asking them month over month, hey, why hasn't issue ABC been fixed yet? Or what's going on with this? But in general, the results do speak for themselves. And so Britton, if you want to go to the next slide. So we effectively started this program 1 year after building operation. So we had a full year of building operation energy use to consider as a baseline. So after 2 years of the program, and the reason why I'm talking about 2 years, because that puts us 3 years into the building operation. And even though the building increased by over 12% after 2 years of doing this program, together ATS and CBRE effectively reduced the overall consumption by 10% over the baseline, normalized to weather, reduced demand by 10%. The utility savings effectively paid for the service as well. In addition, we reduced hot and cold calls and reduced equipment run times, thus extending the equipment life. And what's really important here, and something I want everyone to kind of remember, and I try to say this every time I get a soapbox, is that efficiency, tenant comfort, and equipment or asset life, they are not mutually exclusive issues. They can all be achieved together and not necessarily be diagrammatically opposed to one another. And finally, I want to refresh everyone, remind everyone what Ashray said, or what the past president Ashray said, where he said, most buildings lose 30% of their efficiency in the first 3 years. Well, because of this program, we really went the other way. We actually saved 10%, or more than 10%. So I really see this as like more than a 40% swing towards efficiency.
It's a great storyline. I'm sort of interested in following up with you two about, you brought up the issue of there's some specific issues with the single tenant in this building, potentially some issues with the design, operable windows, et cetera. Does that make this story idiosyncratic to this building, or is this something that's more widespread? Than just this building.
Oh, sorry about that.
No, jump in.
I have to say, I want to expand on that as well with Pete. What you were seeing in that building, was all that value being derived from 1,000 different things, from 10 different things? And if so, are those things that you're commonly seeing across the portfolio that ATS helps with?
Good point there. So interestingly enough, when you turn on the analytics spigot, if you will, it is really easy to get drowned. That's not a spigot. It is a fire hose. And for some people, it turns into it's too overwhelming. There's too many things. And then it's just, you're just paralyzed with too many things to do. So how we started this process was simple. We looked for the lowest of low hanging fruit. And I'll show you one example a little bit later on, but things like 24/7 operation. It's amazing how many things over a year can start running 24/7 because of being an incorrect schedule, something overridden, something manually overridden, things like that. So we really focused on that first year, that low-hanging fruit, 24/7 operations, set points, schedules, things of that nature, resets that got overridden, things like that.
Keith, I'm interested. I know that you're looking at thousands of buildings, but does this song sound familiar, at least in Google's experience?
Sure. I mean, alert volume has always been a huge problem. One of the things that we've done that really turned this on its head is once we had a nice standard building model that we could push all of our data through, we were able to use some machine learning to automatically categorize things and identify rank things by severity. And what we found was that we were able to do with very little configuration to cover all of the critical heuristic rule-based alerts with a system where now we could basically just turn the volume up and down. And so, like, you don't want to overwhelm your operator, so you can just kind of change that threshold of what they see until they work through it, and then you can turn the volume up on them a little bit until they get through all the stuff that's important.
And I don't want to spend too much time on Google specific. I don't want to take away from Pete and Tim and what they've been working on, but Google approaches this from two directions. They take the first, which is this machine learning automated FDD that has zero scalability cost, right? It just sort of deploys to common devices as they come online. But they also have a second side, which is more of the engineering analytics piece that I think we're all used to, where we bucket and partition these analyses by what makes the most sense. Pete's talking about, 24/7 operation, off hours operation, that sort of stuff. We would bucket that as a single analysis, and we would apply that across all of the fleet, and you would be able to see what's happening on a daily basis, and you categorize it, prioritize it based on its overall cost. This is where a wealth of data can really come in handy, like for instance at Google, where they have mechanical schedule information, and they can feed that into a SQL Server data set. Well, not a SQL Server because they're Google, a big query or a big table data set, and you have the ability to merge them all together. You can come up with very accurate, utility grade accurate calculations for how much this air handler is using over time. Pete, you guys have been using, I assume, a lot of that same sort of data to back into these prioritization metrics. These seem to me like they're fairly ubiquitous throughout the industry.
Yeah, I think they are, but at some level too, it's pretty easy to categorize things into how easy is it to fix it. That's the other thing.
Yes.
Things that, geez, that's 2 clicks of a button, just take care of it. Maybe the value of it is relatively low compared to some of those other things, but the cost of fixing is easy. And Tim, maybe you should kind of talk about, you kind of changed how you've been doing some operations lately because of your buildings aren't as filled for some apparent reason lately. And what I'm getting lots of questions from your guys. You guys are really tackling things kind of different. You're being way more proactive now because you have time, it seems like. Is that correct?
Well, it's more so, absolutely. Yeah, but what we're seeing is, being able to trend, which your specific energy consumption, whether it's plug load, whether it's HVAC, and which HVAC unit is has what energy consumption profile. With the change in occupancy, you can still see that the changes in that use pattern. But you can also still see problems. Where are we still consuming too much energy, and we can dig deeper into the specific equipment related problems or operational issues. Is it the increase in janitorial night ops because of now the necessity to increase number of cleanings? You're cleaning every day instead of maybe one day on the weekend, that kind of thing. And so it's a unique circumstance that's allowed us to view the buildings differently and how they consume during this time period, where yet we still have to be open. We're still running the buildings like we would on a normal schedule, just with barely any occupants.
Right.
So yeah.
Before we leave this case study, Tim, I just want to circle back to make sure that all of this has had at least no or maybe a positive impact on tenants. So I don't want to leave the building occupants out of this discussion in terms of between all of the activities that have occurred over the past 2 or 3 years. Reassure us a little bit about the situation for tenants. I mean, pre-COVID tenant.
Pre-COVID, so back in normal occupancies,
right?
Like the majority of our calls, of our work orders that are generated for our engineers are hot or cold related. They're comfort related, maybe draftiness or just depending on where they're sitting in the on the floor in the building. And so the faster that we can react to the things that create those situations, the more likely it is that it won't be a situation. We won't get that work order. a lot of times maybe the change in the sequence, inadvertent change in sequence of operation, or like Pete said, inadvertently overriding something into manual and forgetting to put it back in auto. The daily analysis that and report that we get that identifies potential issues allows us to address those problems, that are related as related to equipment before they become a comfort issue. And as we've become more familiar with the product, with ATS's software and the tools, and we become more capable of utilizing those tools, the better the response has been. We've really reduced our work order load drastically, just in those first few years.
Right. Reassuring. Well, I want to turn us now and dig just a little bit deeper and talk a little bit about sort of the here and now of smart buildings and what systems are typically involved in a smart strategy. We've been sort of talking at the headline level here. I'd like to ask Trevor and Keith to maybe kick off that discussion a little bit and tell us a little bit about what systems are involved here in this process. And Britton, I think there's a slide or two that you could pull up that may support this conversation.
Yeah, I think we can talk about that. Obviously, everyone's familiar with from the base systems, what they typically integrate with. HVAC, the BMS is like number one for sure. Everyone tries to integrate with that to some degree. It's a nice consolidated system, usually very well managed because it's used every day. It's really a system of record for the people that run buildings. And so you tend to see those have the highest level of upkeep. They tend, even in smaller deployments, to be fairly good. Like, depends kind of on where it is and what it is, but like if your best bet of having a good data set is usually going to be through the BMS. And you'll also see on some of these legacy deployments, energy as well. Energy is a very common one, although I've, in my experience, never found that energy metering is, especially in sub-metering, is ever quite up to scratch. Has it been commissioned? Does the data come in any, does it make sense? That tends to be a problem, and you particularly get into that problem with scale.
Amen to that, Trevor. You are spot on. All too often, and I'm just going to use this as a soapbox opportunity, make sure your sub-metering systems are commissioned, because more often than not, I don't think they are, because we get so much bad data out of them. I'll let you continue. Sorry, Trevor.
Yeah. So I guess if we're ranking these in order of most prevalence, BMS tends to be the best, because even a BMS with kind of garbage data in it can tell you something. It relies on that data in order to operate. And so it's actively using, say, a failed temperature sensor or a badly placed outside air temperature sensor to do something. And so even anomalies in the data can lead you to value. Energy meters, those aren't really used for anything other than reporting. So if you've got garbage data going in there, it's going to be a bunch of garbage out and minimal value from that. So I echo Pete's sentiment. Get those commissioned from the start.
I would say properly running sub-meters provide tremendous value. In fact, if the only data you have, you can get a lot out of it. But bad data is worse than probably no data.
I would tend to agree with that. And one of the things that we're starting to see in the industry is more integration from some of these systems that normally would be off the table, right? Like we're kind of all familiar with CMMS systems getting integrated, because that's more or less linked to the way that the BMS is operated, right? Oh, tickets go in, people make changes in the BMS, they go out to the field, they do something, the CMMS gets updated, and so on, right? But we're starting to see a lot more data come in from these secondary systems like lighting. Lighting has a lot of benefit potentially to the BMS to help augment it. A new and lighted system will have occupancy data. And so, for instance, with Google's portfolio, we've got some lighting systems integrated there, and we can get all sorts of occupancy data, granularities we could never get from a BMS because it just wasn't cost effective. Now, if I could only facilitate the interoperability of that data with my BMS, I could be actively staging on and off my BMS equipment based on occupancy that's not directly generated by the BMS. That's really why today is, I think, the most exciting time that we've seen so far in the smart building space, and it's only going to accelerate as the interoperability of these technologies increase. I'll let Keith turn over, or I'll let Keith talk about this a little bit, but AV and specifically the real estate data on CAD and how they ingest that data, I think is really cool because, again, that's another thing that like we generally don't have. You have, you know, a BMS, it tells you, here's the VAVs, but like what zones are they physically tied to? Are those accurate? Do they actually break out zones by room? Like that geospatial component of it tends to be a lot of manual work, and people opt to not do it, especially at scale. Keith.
Yeah, sure. So, like Trevor said, I think data integration is kind of the future, right? And data integration already happens sort of ad hoc in a lot of buildings, like you know, the example Trevor gave with integrating lighting and BMS. Like people do that one-off in BACnet, like a lot of times to get that benefit. But you know, what we really want to do when we're talking about, you know, hundreds of buildings globally is to figure out a way that all of these little integrations are not one-offs, that we have a common model for bringing all this data together. And that's what we've been working on. And we actually have an open source project called Digital Buildings on GitHub that is, we're actually sharing a lot of the modeling, and Trevor's been helping a lot on that with DBEng. And the what we've been doing internally right now is basically building all these systems to take this you know, this data from disparate places. So we have CAD, we have the BMS actually is like the only source of record for what your HVAC zones are, and those that source of record is, you know, a drawing someone did by hand in the BMS, as an example. You know, lighting, which is a completely different system where the floor plans that they use in the lighting control panel are not standardized, and somebody just dragged and dropped the little lighting units onto the drawing, right? We're doing all this work to integrate it, and what we'd like to see happen in the industry, and what we're pushing on for contractors that are building buildings for us, is to push this stuff up the design stack with more standard models and standard formats. So we have a standard way to export spatial information and a standard way to model, you know, equipment types and the points that they provide, so that when it comes in the door in the first place, you can relate things to each other. Today, that's a process that is done after the fact, and that's really, really painful, and we want to avoid it.
And it might be worth just clarifying on that real quick, because I know there are a lot of people on this call and they might not all be familiar with what you mean by a building model. So if you think about a VAV, right, it lives in a BMS, it has data associated with it. It has, you know, a naming convention, you know, presumably from the BMS. And I got a VAV in this building, maybe a VAV in this other building, or another part of this other, of the same building. How do I equate, say, their supply air temperature or the airflow going through them? There's some semantic model associated with that has to be machine readable as well as human understandable. And so when we talk about building models, which we'll be talking about a little bit more as we go through this conversation, just understand that it's that. If you're familiar with Project Haystack, which is a tagging convention that's open source and very widely used in our industry, it's similar to that. Having data tagged and understood well is the most important part to using the data beyond just having it in the first place. So off my soapbox there. I'm a big proponent of organization of data, organizing data in a smart way that enables us to do interoperability, because like you understand, and Pete, you can talk about this because you guys see this all the time, right? Touching a wide variety of systems, is that that adds friction to the onboarding, the integration, the analytics process.
When you mean friction, if you mean cost, then yes, cost and time.
And I'm interested in particularly, Tim, given your experience, not just in the one case study building, but across CBRE, I'm going to presume that different building control system vintages also makes this a more sort of complicated knot to untie. Any comment on that?
Yeah, absolutely. It's, you know, that's, you got to play the cards you're dealt a lot of times, you know, and you're working under the confinements of you know, the budget, you know, and the capability of your team, you know. Everyone wants the latest, greatest, the fastest, you know, the most, you know, the newest technology. But sometimes you just don't have that option. But if there's a way that somebody could integrate, you know, or you know, or build interoperability so that you can utilize some of those tools with this system that you have, that makes life, you know, a lot easier, and you know, and maybe more palatable, you know, when it comes to the actual cost of it, because you might be able to afford this, you know, this integration tool more so than a complete update of your system, because that would include hardware, software, you know, the whole bundle. So
Yeah,
yeah,
great.
there's a lot of interest in these types of solutions. Absolutely.
Great. Well, I want to steer us now to talking a little bit about analytics. These systems produce a lot of data. Data is just data until you do something with it. But there seems to be a lot of general confusion about what we mean by analytics. Is it analysis? Is it a tool? And I'm hoping that Pete can start us off with at least his viewpoint on analytics. And I think, Britton, you can probably just click to the next slide for him.
Yeah. So Stan, you're right. You know, data is just a bunch of numbers until we put some meaning behind it, analyze it. And, you know, over the last couple of years, it's become really apparent to me that because there's a lot of differing opinions or definitions to what analytics means to different people, that it's really just become an industry buzzword that's created confusion and a bit of noise in the industry. And because of that, I feel like some of the adoption's been a little bit slower because of this confusion. So this is my own personal working definition of what analytics means or what they are. And to begin with, I always say that analytics is a tool, but in some respects, the tool itself is irrelevant. And I say that because in this industry, and we'll say the HVAC industry in general, analysis, not analytics, there's a difference, but analysis of data is nothing new. Think trend logs. But it's the technology that's made it so much simpler, easier, and possible to wade through enormous amounts of data from disparate systems, from disparate buildings. So the difference is that the analytic tool performs what used to be a real manual and laborious process. It does it for us. So my definition is that analytics are a tool that creates actionable value from data. That's the first one. And I put value in quotes just because, you know, everyone has a different end goal when using data and analytic platforms and processes. And some people, the goal may be energy efficiency, and others it may be tenant comfort, or maybe for others it's just reporting information that's important. So, so that's my kind of my first catch-all definition. My second one really is, you know, analytics detects patterns, trends, deviations, anomalies from expected outcomes that represent opportunities for better building performance. I believe that's kind of more the classic or commissioning focused definition. But that's how I defined it, analytics. But I think it's really actually more important, if you want to go to the next slide, that to understand analytics beyond just the tool, and really more so that it's more of a process. It's more of a journey. And what I mean by that is when you deploy analytics across buildings, you don't know what you're going to find ahead of time. You know, this isn't like a light bulb, a more efficient light bulb that if you deploy, you know what your savings are going to be. You don't know what you're going to find. If you knew what you're going to find, there wouldn't be really little benefit in the tool itself. So that's why, and a lot of people don't realize this. And then there's been so many times that I thought I was going to find X or Y. I start diving in, and then you really go down this rabbit hole and you find this whole other issue that comes up. Maybe the whole building, you know, how the building was warming up in the morning is totally wrong. So in essence, you know, analytics are really just a tool to make it easier to understand how the buildings are really performing. But to be successful, no matter how good the platform is, you really need a process. And that's what I wanted to dive into a little bit. Britton, if you want to go to the next slide. You really need this process. And I didn't create this process. People have been doing this type of process for years when it comes to service. But this is kind of the process that, you know, working in Tim's building, we chose, and it's simple. You monitor. You have this analytics platform pulling in all this data, making sense of this data, identifying issues or anomalies, whatever they may be. Then you need to analyze it. You need to determine if there's really an issue before you start, rolling trucks or doing work. And an example that just came up this weekend, one of Tim's guys sent an email to me saying, hey, I keep on getting this issue that this unit is running when it shouldn't be running. And he said, it's fine now because the operation of this tenant now, or they're running the unit longer because the kitchen's operating longer. So this is a false positive. So we needed to determine, have someone spend a minute, 30 seconds to determine there's really an issue. Then you need to put together a plan. How are you going to fix it? Who's going to fix it? Then you need to verify the issue's been resolved, and then you just wash, rinse, repeat, and keep on going. So this is my most simplistic version of a process. But if you don't have that process, what I have seen is that people don't have uptake success with this, and then it just becomes kind of a waste of money. So making sure there's a process behind the tool is as much or even more so important than the tool itself.
Track. I think of all the bubbles on there, like it's easy to monitor. It's super easy to analyze. I mean, this is like desktop quarterbacking, right? The planning and the acting, those can be harder, trickier, but man, things regress. Things regress quickly, and when you least expect it. So one of the keys to continuous analytics as a value proposition is that that things remain fixed. Pete, you used to do retro commissioning, I'm sure, for your buildings. Tim, you guys probably facilitated retro commissioning. I've done it before. That you step in, you fix some stuff, and then you walk away for some period of time and come back to it, and you lose that tracking capability. I mean, that's basically the value proposition for a smart building platform, is the ability to not have that happen, fix the problem, and keep it fixed. Particularly if it's something that's coming up as a result of operational misunderstanding. I can't tell you how many times I've seen a team that, they think the air handler or the chilled water system is supposed to operate this way. It's got to have 20 pounds of DP at the end, by God, otherwise it won't work. And it's like, no, it doesn't. And you explain it to some of them, but that information doesn't get propagated to the rest of the team. Next thing you know, you come in and boom, it's right back at its original,
Yeah, I think you're hitting on a really good point, and I'm actually going to kick this to Tim. Part of our process is we have these monthly meetings, and these monthly meetings aren't just like we're talking about, this VAV box set points, at 80 degrees. And no, we're talking about bigger picture things, and it turns into this almost training session of talking about these issues. And you start talking about things like, well, why was it at 20 pounds of DP? It's like, well, that's the way it always was. Well, is that really how it should work? And then it opens up these opportunities to try different things and try to change how the buildings operate. And Tim, I'd love to get your feedback on your thoughts on those meetings you have with your team as we talk about these bigger picture issues and the value proposition there. And this isn't even about analytics. This is just about the process.
Right. No, Pete, as we dig into the feedback from the reports, we get the same reports every week, and then the guy's like, but we fixed that. We took care of that. Why are we still getting, this alert? And we realized that sometimes just the operating parameters of the equipment are just not fitting the mold of what's being looked for. The algorithm parameters or whatever is being set up to pull this data in and assess whether it's, it needs to be addressed or not. And so more recently, we've, digging deeper into the specific nature of what's being looked at and how and the data that's being collected, what it's telling us. We've been able to work with, Pete's team, his field techs, and get these adjusted so that the data they're giving us is relevant. So one single parameter could affect, hundreds of different devices, and they're all coming back saying there's a problem, or maybe there isn't. Without that deeper dive and understanding that, there could be something here, but it might just need more tweaking. Has not only taught our engineers a lot more about their systems, but it's allowed us to root out, false positives, not only problems, but problems with the problems. So it's been the monthly meetings and the diving in, the feedback, it's really gotten the guys engaged. All of the engineers are looking at a lot harder at the results and how can we improve. Just from the information that we are able to get on a monthly basis. So, yeah, it's good interaction. It's good stuff.
No, that's great, Tim. I wish we had another hour because I'd love to unpack a conversation about what all this means in relationship to operations staff and skill levels and what you need to do in order to have this sort of institutionalized persistence of this process that Pete's talking about. But we're going to save that for yet another day. Pete, I don't remember if you have one more slide where you're going to provide some specific examples of analytics. If we could go to that, and then I've got one more conversation zone.
Yeah, this is a quick one. This is about the most simplistic thing. These were the types of things you can see. This is back in 2016. So this is those early days we were working. And Trevor, I mentioned 24/7. There's a ton of there's so much equipment out there, and this is a simple finding before something was running 24/7 when it didn't need to be, and this is kind of that tracking. Hey, it was running 24/7 before. Hey, look, it's operating properly now. And I just wanted to kind of share that as probably the most basic analytic rule that we have. But even though it's the most basic one, there's a ton of value in it. So that's all.
It's the first one I go to whenever I go into a new building because it's so easy. It's so easy to explain, so easy to fix, it's so easy to detect. It's really the gold standard. Great.
Well, I want to turn us to one last conversation zone, and you guys, this has been great, really good discussion. I'm really getting a pretty good understanding about what we're doing and what we can do well. But I'd like to hear a little bit more now about what you guys think that we're not doing, that we need to be thinking about in order to sort of increase our capacity to be smart within buildings. And Trevor, I wouldn't mind if you would kick off this conversation a bit. And I think some of this is certainly going to relate to Keith's challenge in terms of thinking about this at scale, where we've got large numbers of buildings and we're wanting to migrate to this sort of way of thinking.
Yeah. The future of this industry is going to be automation of all parts of the process, right? So if you take a typical building today, some consultant, some engineer, some BMS provider has to go into that building, make sense of the data, map it to something, give it context, integrate it, take protocols that may not be conducive to integration and integrate them anyway. And then they have to put it into a standard platform, and there's 1,000 different standard platforms out there, and it can be hard to interoperate between them. And so a lot of what we have to do today is standardize. We have to standardize protocols. I'll let Keith talk about protocols here in a minute, but the other thing that we have to standardize is how we represent things. One of the things that Keith and I have been working on very, very closely for the last 2 years is coming up with a more robust semantic model for how we call things in the world, how we model them, how we add intrinsic meaning to the relationships between devices so that we don't have to redefine them every single time a new building comes online. Keith, talk, what are you seeing on your side?
Yeah, I mean, so shared understanding of the meaning of data is the crux of the automation problem. You need to be, as an application, all you see is what comes over the wire. And if there isn't enough information in that data that's coming to you over the wire to not only tell you like what the value of that point is, but what that value means in the context of the whole system, you can't do any automation without a human going in and like manually adjusting things. So the key thing is bringing enough context to the information in a standardized way so that when we see a new building come online, we can understand what's coming out of it. And that's really the beginning and the end of it. And you look at, what's happening in the consumer space, right? And we have, a given device. There's a lot of interoperability standards. People implement those standards. Then you buy your smart home IoT device, and you pop it into your system, and it just works, right? And The challenge of doing this in the commercial space is the systems are much more complicated. So that the data representation needs to be much more robust in order to get that same functionality, but we can get to that place.
It's going to require automation. It's going to require machine learning and other things that, you know, I think some companies are out there that they claim to do a lot of this, and I'm sure that some of them do it very well, but it's not a ubiquitous part of our industry at this point. And so a lot of the standardization that we have to do, because we have to do it, Pete has to do it, I have to do it, there's just no way to make a machine understand what something is unless you explicitly tell it, is to do it manually. That's what we have to do. And so a lot of large companies, I happen to work for, my clients are some of the largest companies in the world, and they have good internal standards. Google is an example of this, with good internal standards, but that's not really a solution that everybody can apply, right? Tim, I mean, you can maybe speak a little bit about this coming from kind of the other end of the spectrum, where you've got a couple properties, and it can be difficult to say, thou shalt install this type of system.
Well,
automation is the only way to solve it.
That he wasn't part of the design process, or if he was, they probably didn't listen to him.
Yeah, exactly. It's the way that we solve this is through smarter technology, and you know, Keith and I have been talking with manufacturers about this. BMS manufacturers are familiar with this space, and so they're trying to reduce the friction there in certain instances. But you know, we still have a long way to go before I don't have to do any mapping anymore, which, oh my God, I'm very excited for that day. I would love to be out of that business.
Right.
I feel like we're part of the way there, but there's just so much in that built environment that is so long past that manual process is going to be there for a long time.
It'll be there for the near future for sure. But that's a challenge. I think a lot of the interoperability questions, like protocols, IP being, you know, a big game changer, and that all devices are going to basically speak it. We're getting to the point where the information is going to be available if only we can make sense of it.
Right. And I think you guys have a couple of slides that might help me understand a little bit more about some of these language. I'm certainly getting the point that this isn't just a scale issue. It's not just a problem of going from 1 or 2 buildings to 100 or 1,000 buildings, that there's something deeper and more fundamental there. Britton, if you could bring up those slides, I think Trevor and Keith could probably walk us through those.
Yeah. Keith, you want to walk through?
Sure. I mean, so we all know the problem of, you know, buildings are not the same, right, from building to building. There's a lot of differences between systems. Most of those differences don't matter. There are some differences that do matter. And so the whole idea of a model is to basically take a hold of what you care about. So like, these are the things that I need to make my system perform better, and to capture those in the way that you specify your data, and then to basically ignore everything else, right? And an ontology in this case is a way of defining what you care about and what you don't. So like, it defines a structure of how you talk about things, and then it gives you literally a vocabulary, so actual terms to say, you know, here's what a thing means. And I think we have another slide.
Next slide.
Yes.
Yeah, it's really simple. It just outlines what some of the core concepts are. And
so the key concept that we've latched onto, and you can see Brick was kind of the progenitor of this, and now Haystack is trying to start incorporating it with Haystack 4, is to create what's called semantic understanding. So this is when you have a piece of data, not only to have like the value of the data, but the context of that data. So like, something isn't just a temperature, it's the temperature of a zone, or and that temperature of that zone is the zone that covers a room, right? So having that kind of, that triplet of like, here's a thing, here's a relationship, and here's another thing is really important, because with that basic structure, and clearly defined terms, you can now, in an abstract way, represent your entire universe in a way that a machine can understand. And now, like, if you have building A and it says, I have a zone temperature sensor on this device, and you have building B and it says, I have a zone temperature sensor on this other type of device, but they both map to the temperature in a room that you care about, you can treat those the same, even though you have they're maybe coming from two totally different types of systems. You can still reason about them the same way. And so that's the kind of thing that we want to do across our portfolio. So now we can build applications that understand that data and the meeting and don't have to care about all the details of all the devices that are giving them that data.
That's great. That was really helpful. Thank you. We've got about 4 or 5 minutes left, and that's just enough time to ask each of you to maybe take 1 minute and summarize, if you will, your sort of what's on the top of your mind in relationship to thinking about moving the smart buildings market forward. And I'm going to ask Pete to kick that off.
Yeah, thanks, Stan. And I'm going to take my kind of top line thoughts kind of more from just a strictly analytics as opposed to full on smart building standpoint. But the first point is this. You don't need to be a major corporation like Google with a huge internal facility staff and to benefit from analytics. You don't need to have a fully integrated or a fully smart building to get value out of analytics. It is possible to start small. Maybe just looking at meter data, if you have good meter data, or looking at your economizers, or looking at set points or statuses. There's a lot of value in starting small. So you don't necessarily need to think about deploying across, 100 or 500 buildings or something like that. You can start at a singular building, and that's one of the reasons why we want to share with one building first. The other thing I want to reiterate, since I got my soapbox, is that, again, tenant comfort, efficiency, equipment life, they're not mutually exclusive. And then the third thing, and I didn't have a chance to say it today, but I've said it probably 100 times before, is that the return on investment on deploying an analytics service package, whatever you want to call it, the return on investment is zero if you're not planning on taking action. And I've said that a lot before. Now I'm going to put a caveat there. However, as we're starting to move into the future, and I think Trevor was alluding to this, we're actually starting to test some systems where we are using AI to take some of that action. Now, it's different action than what we may have taken because it's maybe not smart enough to know that that piece of equipment now does need to be running longer, but making minor adjustments to the systems. But still, if you're not planning on incorporating this, there's not a return on investment. Take action.
Great. Thanks, Pete. Tim, you're up next.
That's kind of key, really, what the last point that Pete made is return on investment. In order to get approval for a lot of these projects, it needs to show that it's going to either pay for itself, in one way or another, either through improved efficiency, cost reductions, that kind of thing, and the cost to, for the consulting portion of it, that varies from property to property and system to system, and sometimes that just prices us out of that capability, and that's what we're hoping for, is that down the road, these systems are a lot more amenable to integration, and that infrastructure is available to those of us who don't have necessarily the input at design and construction. So that's kind of my 2 cents.
Great. A good 2 cents. Thanks, Tim. Keith?
For me, it's all interoperability standards. Like, we need something, some more robust way of representing data that includes semantic information that manufacturers agree on, that we can then use in applications.
Perfect. Trevor, you get the last word.
I'm not sure what to say. You guys have covered it all. I would my final thoughts here. I would give to the people that are still on this call some hope. Right, we've done a little bit of poking holes into the state of things today, but this is by far the best time, and it's only going to get better for smart buildings. You obviously have to be pragmatic with what you're going after. You can't integrate everything if you don't have an unlimited budget. Right, you have to be careful that what you're looking at is actionable, that it has value if you do take action against it. These are all very common sense things that you need to take into account. And one of the things I've seen, I've done it myself, and I know, I've had clients that kind of continue to do this. They get enamored with the data. They have the ability to ask these questions, and so they ask certain questions that like don't merit answers, right? be practical about what you're doing. And the industry is trying to do a lot of stuff to ease the friction associated with integration that will hopefully make it so that a lot of the things that we have had to do up until now are just things of the past.
Perfect. Thanks to each one of you. It's been a really fun and enlightening discussion today. Really appreciate your contributions. Tomorrow's day 2 of Smart Buildings Week. We're going to have an equally interesting panel talking about grid interactive and efficient buildings, so that I hope you can tune in to day 2 tomorrow. And thanks to you all. And that concludes today's webinar.